physical magic, whether it is magical. In the last episode, you discovered that if you have an object that is not just a point mass, and it is placed and it has a pivot here, pivot, another name, fulcrum, hinge, and it can rotate in this position. Some of you, if you want to make it easier, is the center of the rotation. Let's say it can be turned like this. In order to make it turn, you have to apply a force. And the perpendicular distance and when you have all this, you have a new equation called moments. So moment is equal to value of force times the perpendicular distance. Another equation that we need, if the object remains in equilibrium, means you have a seesaw. If you are standing here, that's why the object falls. But if you have a friend here, the most obvious thing you can say is the seesaw will actually turn. So most easiest is say, of course, seesaw will turn clockwise. So in this way, this is clockwise. Most obvious. But what happens if it doesn't turn? What happens if the whole object remains stationary? Okay? It can only remain stationary if the turning effect here and turning effect here is balanced. To make it easier to understand, maybe this isn't a perfect equation or perfect example. What happens if you have a seesaw that is very balanced? If you put someone standing here, you will expect the seesaw to go down. But before it goes down, you place another person here. And it remains still balanced. In this case, it remains stationary. How is that possible? This guy will create a turning effect in this direction. This guy will create a turning effect or something called moments in this direction. So that this leads to a conservation. So principle of conservation of moments, which states that the summation symbol of your clockwise moments will be equal to the sum of your anti-clockwise moments. So clockwise, this direction, positive, and clockwise, this direction will be your anti-clockwise moments. More questions directly, quite easy. So instead, we're going to go to questions related to Hokong or to the conservation of moments, so that you'll be able to see the full interplay of how objects, when they're stationary, how do you find what is the force or what's the weight on the other side. Again, a reminder, since I just stated just now, moments are not momentum. Why? Momentum is mass times velocity. Moments is force times perpendicular distance. Mass is kilogram, velocity is meter per second, force is, let's break it down. Let's do something called homogeneity and break it up as a base units, perpendicular distance. So you got kilogram, meter per second squared times by meter. You end up with kilogram, meter squared per second squared. Notice different SI-based units. When they are different SI-based units, means they cannot be the same physical quantity. These two are different physical quantities. Okay, in the next episode, we try and use the conservation moments to answer the question.